Welcome back to the channel, everyone. This is Bob Martin, the RCSubGuy with the Nautilus Dry Docks, and we are continuing our saga of the build of this 80-inch Deboer Seaview for full RC control. Thanks for joining me. So, since the last chapter, a couple of things got done. We got our 3D printed bulkheads, have all been obviously fabricated and installed. They were tacked with CA glue in the appropriate locations, and then I used RTV to fill the gap. So basically, each one of these little chambers is a little self-contained ballast tank, with the exception of the fact that there will be about a 1/16 inch gap at the top of each for air to move through. So it will act as a single ballast tank, but these ballast tank bulkheads will stop the water from sloshing back and forth if it is in a partially filled condition, which really should not be that often. Most submarines are going to want to be in either fully surfaced or fully submerged state. The other thing we got going on here, I have begun work on the watertight compartment. This is going to house the pump, the receiver, the speed controllers, the pitch controller, the remote on-off switch, and all those other goodies that really don't like getting wet. Got waterproof connectors in here that I'm getting all hooked up, and a bulkhead for the main power that we are going to run from our little battery pack. And then the other thing that I just did a minute ago is I frosted the ballast tank lid. I just think it's going to look a little bit better, a little cleaner, a little more dynamic. Should look pretty cool. I'm going to let that dry. And then once it is, we're going to carefully as possible, feed it through the flying sub bay here, up into the main area of the boat, and then RTV it down into place. There should be no reason to access the ballast tank afterwards. There's no components in there, and there is obviously a channel where we can pull and feed wires through if for whatever reason we may need to do that in the future. So that is where we're at right now. I am going to continue work on the watertight compartment here, rated to 80 feet of depth for water integrity. So I love these things. They work really well. These form the basis for my RC Sharks and all other sorts of projects I got going on. So things are looking good. So we're going to keep going here. And maybe by the end of the day, we'll have a quasi-functional watertight container. Okay, new day and more work on the Seaview. I am happy to report that the watertight box has been completely built, assembled, tested, and is completely ready to go. I'm going to show you everything working, and then I'm going to pull it out and show you what everything looks like inside. I'm really happy with how this turned out. We got the power cables for the battery all rigged up here. The ballast tank lid has been secured, and I painted over the interface there, over the seals, so that it looks a little cleaner. I love that frosted look. I think it looks awesome in there. I just installed the 4 solenoid valves, and waiting for that RTV to kick off. Tested and calibrated the servos for the rudder and dive planes, and checked the motors. But I want to show you how all this works here. So I got the radio on. I'm going to go ahead and see if I can plug this in one-handed. All right. Now, I just plugged it in. The main boat is not on right now. It's got these on-off switches that turn it on. But you'll notice the LED lights are on. Yes, they are. Now, I've done this on purpose, because one of the things that always ends up happening is people forget to unplug the main drive battery from the boat, even when it's turned off with these remote on-off switches. And if you do that, the on-off switches have a small parasitic draw on the battery, and they will kill that thing dead inside a week. So I did this intentionally rather than poking another hole in the box and running the light circuit out after the switch. It's before the switch. So now you have a visual indicator that the battery is plugged in. Even though the boat's not on, you can tell that your main drive battery is plugged in and that there's current draw on it. I think this is important just to make sure that you don't end up killing your battery. You'll notice too that the rear lights are on. These are incandescents. Now, one thing I noticed, this guy right here, from time to time, yeah, it goes out. And you touch him and he comes back. I am not going to do anything with that. It is so deeply embedded in here. There is no way without cutting all of this out to swap those out. That would be a massive undertaking. I think what I'll do is I'll just secure this in place with a little bit of thin CA. And hopefully it keeps it locked in place. But like I said, we got the power on now. We're going to hit our switch. And we heard the magical startup sequence for the motors. You can see we've got our rudder servo. And there's our deflection. We want about 30 degrees coming back out here. And the beauty of this design is that as soon as you kick throttle on, you're going to have immediate yaw response because these are directly behind the propeller. So it doesn't matter how quickly the boat is going, it all depends on how quick your motors are spinning. So that's that. And then we've also got our dive planes. And you'll notice I've got just a tiny little bit of upward tilts on there in the neutral position. And that's done intentionally because these boats really like to do nosedive when you get them up and running. The other thing we got going is our air pump. You can hear that. Now it's running weird. I gotta check it. I'm hoping it's not the pump. I'm hoping maybe it's the relay module or something. I don't know. It's running weird. Maybe it needs the carb adjusted. I'm just kidding. It does not have a carb. But I got to figure that out. But I've got the inlet that will come from a mast in the sail, and then the outlet, which will go up, back, and into the ballast tank. And it'll probably go in right about here, and then all the air will spread out all through here. I really do want to get this working optimally because that is a lot of air that needs to get pumped. A lot of air. And then the last thing we've got are throttles. Now I've done something interesting with this. I've actually put each of the motors on an independent pot here. That's not going to be the primary way of doing it. Now what I want to do, and I have not played around with this, in the neutral position, I want you to be able to control each motor independently. So maybe you can do a stationary turn. Now it would be painfully slow, but if you're stuck, against a dock or something like that, you will have differential steering. What I want to do though is mix these channels so that when I hit the throttle, both of the motors will kick in. So I need to play around with that. I've not messed around with mixes. I'm definitely not an expert. I'm learning. These new radios are all a learning experience for me, but they're hugely flexible. So I think we can do a lot of really cool things and potentially even make it so that when you flick a switch, you could go from differential steering to standard throttle. So I'm going to hope that works out. If not, I'll just split them and put them on the throttle. Not a big deal. Then of course, well, we've got our throttles. We can kind of sounds like a truck, but I think we're gonna get it smoothed out. I'm gonna check it, make sure there's no big vibrations going on there for some weird reason. It also really needs a little bit of grease back there just to keep everything moving nicely. But everything is working. I just got to wire up the vent solenoids and put those in. And gosh, we're going to be pretty close to throwing this thing in the water. All right, I promised you a closer look at the waterproof box. Now, this is put out by a company called S3, and this is their 2000 model. You got the 1000, the 2000, and the 3000. So this is like the medium box. But this is all self-contained, and these are rated to 80 feet in depth and to remain watertight. I've used these extensively in other boats, and they work really, really well. Let's take a look at the outside here. So you can see we've got our main power connector here. This handles the outputs for the 2 motors, so 6 wires for the 2 brushless motors, and then 2 wires for the solenoids for the vent. And then we've got a little tap out here with a mini Deans, and that is going to be for the gas backup solenoid. This is going to have a butane gas backup system. So a little butane reservoir, you hit the solenoid, it vents into the ballast tank, displaces the water, up you come, and then you can kick in the low pressure blower and vent the tank the remaining, or blow the tank the remaining amount. Now, before we get comments going all crazy in the bottom, butane is flammable, you're going to blow your boat up. People have been using propel gas, which is equally, if not more so flammable than butane for decades without issue. This is not a problem unless you're standing over your ballast tank with a lit cigarette or an open flame or something like that. You will be fine. Other things to note, we got the inlet and outlet for the low pressure blower that I'll show you here in a minute. You got little whiskers sticking up on the top. These are the 2 redundant 2.4 gigahertz antennas. So when the boat is surfaced, it's running off 2.4 gigahertz, and you could literally drive this thing like a mile away and retain really, really solid connection to it with your transmitter. And that is pretty well it from the outside. Now, to gain access, you flip the latch, and open it up. That's it. No prying, no seals, no caps, no nothing like that. Let's take a closer look inside here and show you all the goodies. So I know it looks complicated, and for some people perhaps it is, but really it's pretty simple. We've got the big gigantic air pump underneath right here. This should be putting out about 12 liters per minute, which just happens to be the exact capacity of the ballast tank. So in theory, 1 minute, we can fully blow out the ballast tank, which for a tank of this size is perfectly fine. Got the receiver. This is a 10-channel tandem receiver. And when I say tandem, what I mean there is that it's operating on both 2.4 gigahertz and 900 megahertz. 2.4 for when you're surfaced and 900 for when you are under the water. These are the 2.4 antennas we saw a moment ago, and the 900 right there. Inlets and outlets for the air. Got an automatic pitch controller for the rear dive planes. Should keep this thing on a nice even keel. The remote on-off switch. We got 2 big 50 amp electronic speed controllers right here. And then we've got our electronic relay module right here, which controls both the vent solenoids and the air pump from a single channel, which is pretty cool. That's an M-Tronics heavy-duty switcher module. And then last but not least, we've got a little power distribution block right there that takes the 12 volts in and disperses it to all the various things. That's it. Pretty simple. Like I said, this looks complicated, but really, I think everything fit in there really nicely. It's easy to get at everything and pull out components to work on them. I think is going to work out really well. One thing you got to make sure you do or do not do is trap the wires in the seal when you close the door. So it's a good idea just to keep the little wires away and then close it up. And you are done. This is going to get held in place. It's got a little bracket there that it sits in. And there's going to be a ring of Velcro that just Velcros it down. And that's it. All right, we've got the solenoid valves all wired up here. So comes in from the box and then in parallel with all 4 solenoid valves. And I do have the boat powered on, or the radio powered on, so I'll turn the radio on, or the boat on. And now you can listen for the solenoid valves. And they sound way louder than they actually are because this is basically a big drum in here now, which is kind of cool. But the ballast system is working. So we got the air pump and the vents. Next up, we are going to be drilling through here. And I just want you to note, I almost made a boo-boo. This is where I wanted to put it, just below the deck. But if you look inside, there's reinforcing steel in here that makes this really, really rigid. I would have hit that directly if I would have gone through. So I'm just going to lower it a little bit. It's going to be down about an inch from the edge of the deck, but I think that's fine. It'll come out, up, out, over, right about there. So time to drill some holes. Happy Thursday! It's workout day at the dry docks. We had a little workout and now we're back in the shop. Last night before I left, I got all the plumbing done for the vents. And so now all the solenoids are rigged up in series. So they all come on and all turn off at the same time. And they're on the same toggle switch as the air pump. So flick the switch one way, the air pump comes on, the low pressure blower. And then flick it the other way and the solenoids open up and it goes down under the water. Air will, in theory, flow out these little hoses and then out these little vents that I made. So this is just brass tube with a little brass washer on the outside there. Make it look like it's supposed to be there. But basically right now what I'm waiting on is the pressure vessel that I ordered for the butane gas backup, and that I'm going to need to find some room for it. I might put it here just so that the backup situation is all kind of self-contained, or ideally it would be below the water line, but I really don't have a lot of room for that kind of stuff. So we'll see. Once I get it, I can mess around with where I am going to end up putting it. But that done, this will be ready for the water. I've just got to grab the sail and work out the air hoses for that. And yeah, it'll be ready for the water because the cosmetics, the paint and finishing and weathering and all of that stuff is going to be last after we've done all of the trimming and made all the changes and everything that we need to make. So might need to set this aside for today. We get lots going on. Nathan is going to be stopping by here at about 11:30. He's a friend local here in the Woodlands, Texas. And we're going to work on some programming for the radio. We're going to do some cool things with mixing for the throttles. So that is pretty exciting. We'll film all of that for you 900 megahertz guys that are using our FreeSky tandem radios. So Nathan was just out here and showed me a bunch of radio stuff, and now I am super excited about what we've got going on here. I'm going to plug in our boat, and I'm going to do a little show and tell. The other thing I want to show you, I've got this this cool unit called a Watts Up, and you plug it in between your battery, and it'll show you current draw, voltage, and all sorts of cool stuff. I am interested to see what the current draw of the boat is with the various functions. So we're going to take a look at that. So right now, just the LED lights and the other lights in the back there are drawing about 230 milliamps right now. So good to know. I got the radio turned on, so I'm going to fire up the boat. So in idle state, we are at 0.42 amps, so 400 milliamps in idle state. And that's basically the receiver sucking power, and the other ESCs just in quiescent state. So taking a look at this when we move it, servos don't really draw anything. I'm moving the servos right now. They're not drawing anything hardly. We're still at about 350 milliamps. But I'm interested to see what the ballast system does. So I'm going to turn on the air pump. So that's about 1 amp, which would be, I guess, about 600 milliamps. That's not bad. I can live with that. And now the vent solenoids. 1.3. So that's about an amp. That's not bad either. I can live with that too. And now we are going to fire up our throttles. So that was about 2/3. Got up to, what was that, about 1.6? That was like 3 amps. So, I mean, obviously in the water it's going to be drawing a lot more than that. But really just what I'm looking for is to understand, the current draw and what the various components of this thing actually end up sucking in operation. Now, I want to show you what I ended up doing here with the radio. Now, what I wanted to do, the way I've got this set up, I've got each of the throttles set on an independent potentiometer here right now. So if we take a look in the back there, I don't know if you can actually see them moving. Interesting, maybe. So if I move, there's our right motor and our left motor. So I could say, for example, put the left motor full forward and the right backward. And that would create torque about this point that would, in theory, spin the boat. Now, do I think it's going to work really, really well? No, it's not going to. They're too close together and it's too big of a boat. But would it get you out of a bad spot? Yeah, I think it probably would. So that functionality is in there. But of course, you don't want to drive this thing having to work each motor separately. So what we've got rigged up now, you just flick this switch, and now the throttle has linked these two together, and I can use just this stick in forward and reverse. So this would be normal operation, normal throttles, and then if I want to do the steering, just flick the switch and these come back in. And of course they're locked out when the switches are in the other positions. So that I thought was really cool. The other thing that we got is a live voltage readout of the main drive battery. You can see this is reading 12.2 and 12.24. So we got a live readout of the voltage of the main drive battery. And the other thing I got set up are some timers. So as we saw, the air pump and the vents do take a not inconsiderable amount of voltage or current when they're operating. And being that it is a 3-position switch, it could be that you dive the boat and then just leave the vents open by accident. You don't want to do that because it'll be sucking an extra, amp of power that you don't need to be spending. So I've got this set up. So for example, if we were to dive, we would want to move the switch down, dive. Now we see a timer has started. And based on our calculations, it should take approximately 1 minute to vent. So I've actually got it set up where at 1.5 minutes, if you have not returned this switch to the center position, the neutral position, an alarm will beep, reminding you to close the vents. Now you'll see when I put this back into the middle, that vent timer resets. Similarly for the air pump, if I activate that, the timer starts. And resets when I return it to 0. So just a couple of really cool features that are built in to these new radios. It's just a matter of programming everything in. I'm excited to see how it works, and you can obviously modify those timers, so set it almost exactly. So when that tank is done venting, you'll know, let's say it takes an average of 64 seconds, you determine it takes. You could set that timer to 70 seconds instead of the 1.5 minutes. So it's safe right now. Worst case scenario, you'd be running for an extra 30 seconds or so. We'll see. Hopefully that's the case. But other stuff that we've done on the boat. I have added a third servo cable because I, like an idiot, forgot that this thing has Fairwater planes. So let's see those things in operation. And I got those set up on a slider on the back here because the primary pitch control is still going to be handled by this stick. And then the Fairwater planes are here. I don't know if they're really going to be useful, but we'll see. They're huge. They may work really good. And if they do, it'd be a simple matter of just switching these two channels around on the transmitter. And then we would be using this for the Fairwater planes as opposed to the rear dive planes. All right, it's Friday. We are winding up the week on Seaview here. A few things of note. I have drilled the inlet, I guess it'd be the inlet to the ballast tank or the outlet from the air pump, into the side of the ballast tank. So that is where the air is going to be injected into the ballast chamber to displace all the water and surface the boat. This connects to one of the top ports on the watertight box, just like that. And then I have the other hose coming off of that box that connects to the snorkel intake here. And that is a nice tall mast that drops in just like this. And the hose is going to connect to the bottom of this. And you can see if I swivel this, that's the intake for the ballast pump. So this is going to go just like that. So long as this is above the water, the boat will be able to surface. If you're too deep for that, then that's when that gas ballast system will come into play. But that probably doesn't even need to happen because the boat will be slightly positively buoyant. So the only reason there should be a massive issue with this thing resurfacing is if the watertight box takes on a significant amount of water. Unlike a large watertight cylinder, we've only really got that one compartment as a point of failure. And there's no, seals for rotary shafts or linear shafts or anything like that. It's all a physical seal. So should be relatively low probabilities of anything like that happening. Went ahead and primed our flying sub bay door and installed magnets on the bottom. And if I can figure out which way is forward here, we can show you which way this goes. I think it's like this. I don't know, we'll see if it snaps into place. Dunk, just like that. And that's going to be nice, positive lock, easy to remove. You just kind of push at it from the inside there. Lots of room inside there for the flying sub once we get working on that thing. The other thing that I did is I put a wire guard in place here, a little panel to stop the wires from pushing into the flying sub bay. So that's all kind of segregated. And Logan, what are you doing?
I am drilling some holes for alignment to bolt the two of these parts together.
So how is this all going to work when we install it?
Well, we would put the front section in. Once that is locked into the hull, load the back section in, then screw it on.
Bolt it together, yeah. And we've got 2 wire sections here, right? These are separate wire circuits, I guess you could call them.
Yep.
But they've got to be separate. So we're going to need to connect them together with these little mini Deans, so that everything can be taken apart, because you always build to take it apart. And then this will connect to the main lighting circuit diagram thingy. And I think, yeah, I'll have to think about it. If I remember correctly, the way I had this rigged up, we'll have the ability to provide a separate, let's say, 9-volt power adapter. So if the new owner wants to display this boat, I don't know where you display it in your house, but if you wanted to display it and just have the lights come on, he could just plug in the power adapter and just the lights would come on without having to worry about all the guts and gizmos for the RC operation. So that was foresightful of me. So yeah, we're going to get that all done. My butane pressure vessel should be showing up today, but probably by the time it shows up, I won't have a chance to work on it. So it'll be first part of next week. But really, I could, in theory, dunk this whole thing right now and test the ballast tank and everything, but I don't want to do that until I have the butane gas back up, because I want to test that subsystem at the same time, because this is a big, ungainly boat that's a pain in the butt to move around and put in and put out and all that stuff. Not to mention the fact it's raining like crazy here right now, so that's not exciting either.
All right, we're about to install the forward bridge. The installation procedure is pretty simple. You just go up through the bottom of the bay doors, starting with the front of the bridge.
Gotta figure out if this was like front first or back first. There we go.
There we go. Front's in, slides nice and all the way forward.
All right.
Grab the back. Should be as simple as putting the back in. We just added some bolt holes to it as well, so we can bolt the back to the front, keep them both secure. Yeah, so we need to fold a few of the LEDs, or the back of the LED wires, out of the way, but once those are done, we should be able to... Oh, there we go.
There we go.
And perfect.
Where's the cable? Got pushed off to the side there. I'll have to fish that out. Then we can hook those together. Bolt. All right. Well, let's grab our bolts and we'll see if we can bolt this thing together. We might not be able to.
Yeah, I don't think we
Now
can.
that I look at this.
No, there's no way we can.
Excellent.
I mean, they line up pretty well, though. If we look at it through the front, all looks pretty good.
I mean, it looks really good. We just got to make sure we can hold this in place. Which may be as simple as just making a wedge to go underneath right here. You just,
Oh, yeah.
And that'll be it. All right, well. Let's see what we can. We'll fish out the wires and take it from there. So, a little bit disappointing because we just discovered with the rear bridge module in place, the main control box will not fit. We thought we could kind of sneak the cables under it, but it goes down too far and it would just really make it awkward to install and uninstall this. It would make it prone to, damage and breaking and all sorts of badness. But you can sort of see, it has to go in this way and then tilt down, and you see it's hitting this little rear room there. Now, one thing we could do, we could cut that rear room off. It would still be
Awkward.
and awkward and a pain, but it would be doable. Are we going to cut it? That would solve the problem, and it would allow you to keep your super awesome bridge
Permanently in.
permanently in. And really, it's just like what's visible through a little tiny door. All right. We have a game plan. Time to bust out the saw. Well, there we go. We lopped off the back room, ran it through the bandsaw, came off nice and easy, nice and quick, nice and clean. Did that hurt your soul a little bit?
No, not really.
No?
As I said, I couldn't really do anything in the room. It's got, like, some silver stuff that I barely managed to paint, so...
It's going to be so far back, like, you'd have to get your eyeball right, you know, in there to make any difference. And actually, this is going to be way easier to install now, too. Just gotta give her a little wiggle. Wiggle, wiggle, slide. Okay. That is where that fits. Now we just need to see if we can get the watertight box. Alright. Moment of truth. Clicky clicky. Needs to be pushy pushy, clicky clicky, twisty twisty. Oh! Damn, dude, we did it. I stuffed the wire in there by accident. Let's try that again. There we go. We had a big cable running into the back of the room there. There. You can push those wires down, you won't see them. How's it look? You know, it looks like, because you can see the box, it kind of looks like a corridor around the back. Alright. We did it! Now we just need to bolt it all in place, and we're good to go. So now that we're so excited that we've got that rear section in place, we need to figure out a way to lock it in place permanently. Now the forward section got bolted from the bottom with 2 M3 nuts on the support bracket. So that is locked into place. The back one is just kind of sitting on those brackets right now. Now it's locked in the front, side to side, but there's nothing stopping it from moving up and down or back and forth. So we came up with this idea. This is just a brass bracket that we bent up using the brake on the vise there. So the way this works, we just drop this down over the top of this little stud, and we've got a little bit of foam tape on the back. So we got some squishy wiggle room. Push it up tight, nice and snug. We've got a little brass stud. Torque that down. And now this doesn't even so much as rattle or wiggle or anything. I think we're in really good shape. All right, this is going to wrap up chapter 4 of the Seaview build. Just to recap where we're at right now, we got the interior all done, we got the controls all done, the vents are all done, everything is looking really, really good. Next week, we're going to be installing the butane gas backup system. And then from a functional perspective, this is going to be completely done. We're going to be on to test and trim. And then if that works out, we will be testing it and moving on to cosmetics. I really hope you enjoy watching these videos as much as I do in building this boat. If you do like it, please like and subscribe. It helps us out at the Dry Docks a lot. Feel free to drop comments and questions down below the video. I do check it as often as I want, but if you want an immediate response, Bob at Nautilus Dry Docks is how you will get it. So with that, on behalf of myself, Bob Martin, the RCSubGuy, and have a great day, and we'll catch you next time.